Right, so yesterday we solved quadratics by graphing. And really the only new part of yesterday's lesson was that after you graphed, you took it that one step further and looked for the zeros. Right? The zeros, the x-intercepts, were the solutions. Right? You have to take it one step further to find a solution. But what's the downfall? Like, what's the bummer about solving by graphing? Zach? You have to graph it. And especially if they give you a problem without a graph already made, right? You have to create your own graph, which we don't like to do. Or if they give you something that ends up with decimal values, right? Nobody wants that either. So factoring is another way of finding the solution to a quadratic. So we're going to factor. And the good news is, look, right back here, page 70, choose a factor method. I mean, look at all this factoring that we've already done. So we already know how to factor. We just have to kind of rely on these previous notes that we've taken. What do you think is going to be especially helpful today in factoring? Factor notes. What specific note? Your factor squares. Factors of 20 that have a sum of 12. Right? If you can't do that automatically, you go to that factor squares and it'll help you. All right, so we're on page 77. Solve quadratics by factoring. So like we just discussed, if you, might be a little crazy, but it's all right. If you were like, absolutely not, Mrs. Long, I don't want to factor. Don't teach me a shortcut. I want to graph everything. You can still solve by graphing. But for some problems, factoring is faster. Easy to say that today we will be factoring everything. You're not going to switch back and forth to graphing because I'm not giving you any graphs. So if you decide you wanted to graph, you'd have to create your own graph. And so we talked a little bit about yesterday on your notes, solving by graphing. The change is our quadratics, when we solve, no longer equal y. It's no longer y equals or f of x equals and then the quadratic. It's 0 equals. The 0 is the indicator. 0 equals indicates you have to take it one step further and find the answer. So that's this thing called the zero product property. And the zero product property is, I mean, just as straightforward as it can be. The zero product property is when the product of two or more quantities equal 0. The zero product property is when the product of two or more quantities equals 0. So let's go easy to begin with. Are you ready? If I had the quadratic y equals x squared, hold on, I have to make this work, plus 4x minus 21. You could totally graph that. You could find the axis of symmetry, you could find the vertex, you could plot the y-intercept, you could substitute values, you could graph it, reflect and connect, all that good stuff. However, they didn't give us a graph. And, I mean, this negative 21 is an indicator that that's something I don't want to graph. Why is that an indicator? It's too small, right? I mean, it's way too low on the graph. That's my y-intercept. I don't want to have to make a graph that at least goes to negative 21. Do you? No. So, instead, I'm going to factor. I'm going to change it so that it's 0 equals x squared plus 4x minus 21, telling me that I can solve it, find an answer, but we're going to factor. Of the factoring that we did, this is an easy factoring, right? This is not an Xbox method. This is not split the middle. This is easy. So I'm looking for factors of negative 21. What times what equals negative 21? But when I add them, I get positive 4. I can factor it. Close. I mean, this is possibly the most difficult part of it. Because once you factor it, we can solve it. So here's what we do. 1, set equations equal to 0. Right? That was step 1 right there, right? Step 1, set it equal to 0. I mean, that's kind of a dumb rule, right? I mean, you could still technically factor it even if it wasn't equal to 0. You still did this process, but it's really important, and I know it sounds so ridiculous that I'm saying, like, no, set it equal to 0, set it equal to 0, set it equal to 0. You have to get in that habit so that when you have to start writing it in standard form and moving things across the equal sign, you remember that it has to equal 0. After you set the equation equal to 0, you factor the equation . It's easy, or it's either going to be easy, or you're going to have to do X box, split the middle. Your choice. I mean, I guess you could try to factor it, and it could be decided that it's what? Non-factorable. I mean, then if you can't factor it, if there are no factors that work out, then you can't solve it by factoring. And here's the new part. So I guess let's put a number 2 next to this. And the new part. Right? I mean, we've already factored before. We've basically already done step 1 and 2. I mean, step 1 is just changing it to 0. We've already factored. Now, we're going to split apart the factors and solve. So, split apart the factors and solve. I'm going to take x minus 3 equals 0, and x plus 7 equals 0. Zach.
So just like
And kind of reverse what?
just go in the middle because I think that was that way.
Yeah, kind of. I'm going to show this step even though it's kind of redundant at this point in algebra. So x equals 3. Or x equals negative 7. Or and x equals negative 7. And I'm done. If I would have graphed, I would have gotten the same thing. This parabola would have crossed the x-axis at 3 and at negative 7. It was just going to be huge. So we don't want to graph it. All right, this is going to need to be trimmed a little bit. I didn't plan that very well. It's like one line too long on mine. I folded it in half. All right, so you get this in there. The first problem we're going to practice with is a quadratic, but it's not a trinomial, correct?
Yes.
It's a binomial. It's a quadratic binomial. I mean, it's quadratic, so it's still going to make a parabola, so it still will have solutions. So I'm going to set it equal to 0. But because it's not a trinomial. It's not an Xbox problem. It's not a split the middle. It's not an easy just look for factors of C that have a sum of B. So what can I factor out of this problem? I can still factor it. Yeah, they have a greatest common factor. I can take an X out because they both terms share an X. So X squared divided by X leaves me with X. And negative 5X divided by X leaves me with negative 5 equals 0. And I factored it. And can I continue to factor, or am I done? I'm done. So set it equal to 0, factor the equation, split apart the factors, and solve. My factors are X equals 0, which is just done, and 5 minus X. Oh, no, that's not what I wrote. X minus 5 equals 0, which is X equals what? How many solutions are there to this quadratic? 2 solutions. What are the solutions? 0 and 5. Would this parabola open up or down? Up, because A is positive. I mean, it's that easy. You could even, I guess, if you wanted to, make a quick sketch. Well, if it intersects at X is 0, and it intersects at X is 5, and it opens up, I mean, I'd have to do a lot of estimating, but, right? Okay, try another one. X squared plus 7x plus 10 equals 0. X squared plus 7x plus 10 equals 0. So again, we look for factors. We look for factors of, this is a trinomial, so I can do factors of 10 that have a sum of 7. What do you get? What times what equals 10, but when you add it together makes 7? And I get that this next part sometimes gets a little redundant for some students, of saying x plus 2 equals 0 and x plus 5 equals 0. Some of you are going to do this next part mentally, and that's fine, as long as you take a second to really think about it, because I do not want you to say, oh, the answers are 2 and 5, because that's not right. The factors are 2 and 5. That's a good question. So Zach asked, wouldn't it always be the opposite? And if your x squared, if your a value is 1, yes, it would always be the opposite. But if your a value was something other than 1, it would be something different. Right, so Zach asked the question, is it always going to be the opposite? No. All right. Yes. Okay, so let's try. Let's try this one. X squared plus 2x equals 8. Well, there's a problem. It's step number 1. This problem does not equal 0, but can you make it equal 0?
Yes.
So x squared plus 2x minus 8 equals 0. So now it equals 0. Instead of graphing it, I'm going to factor it. So are there factors of negative 8? What times what equals negative 8? But when you add them together, makes 2. What? Negative 2 and positive 4. What are the solutions to this quadratic? Where is it going to cross at? What are the solutions to this quadratic? Zach?
X equals 2 and x equals negative 4.
Good. All right, let's try one that's not so simple. Oh, man, I am super delayed. 2x squared plus 5x, I know it's coming down, minus 3 equals 0. 2x squared plus 5x minus 3 equals 0. 2x squared plus 5x minus 3 equals 0. This is not an easy problem, correct? I mean, first we look, does it have a greatest common factor?
No.
No. So now we look, it's either going to have to be X box or it's going to have to be split the middle. You choose. You may need to go back and refresh your memory on X box and split the middle. Remember, X box is 2 times negative 3, which is negative 6x squared. Put the b value down below, which is 5. Holy smokes.
There it is.
I am super delayed. Nope, wrong one.
That's why.
So, factors of negative 6 that have a sum of 5. Negative 1x and 6x, right?
What?
Factors of negative 6 that have a sum of 5. Three and 2, but do you get positive 5 with 3 and 2? Two x squared minus 3. And then my factors that I found go in the sides. If you were a split the middle person, it's the same thing. You did but you put these in the middle. So then you do 2x squared minus 1x plus 6x minus 3. And split the middle and factor. You're going to get the same answer no matter what. So that was x. That was 3. This is 2x. And this is negative 1. Is that right? Here, when you split the middle, remember these have a greatest common factor of x, leaving behind 2x minus 1. These have a greatest common factor of 3, leaving behind 2x minus 1, making your answer 2x minus 1 and x plus 3, which are the same thing here. Now here's where Zach asked, isn't it just the opposite? It's the opposite here. X plus 3, what's the x value? Yeah, this one's negative 3 because x plus 3 equals 0 is x equals negative 3. This one, 2x minus 1 equals 0. You add 1, so you get 2x equals 1. What does x equal? 1/2.